right? It can be any liquids.
Yeah, it can be any solvent. It can be any solvent. Okay.
Okay.
Water is universal solvent. That's why we use water.
Hmm.
Yeah, okay. The solubility curve is basically, okay, it's a curve which is plotted between solubility versus temperature. It's a graph between solubility and temperature. And solubility we take in gram per 100 gram of water, right? And
Yeah.
temperature we take in degrees Celsius. Okay, so basically solubility curve is a graphical representation of amount of substance that can dissolve into 100 gram of water, right, at a specific temperature. So see this
Okay.
graph, let's see this graph. So we take temperature in degrees Celsius on the x-axis, right? And on the y-axis,
Hmm.
we take the solubility of substance in gram per 100 of water. Okay,
Okay.
okay. So as we know that with the increase in solubility, what happens? The temperature increases, right? Or we can say
Hmm.
that on increasing temperature, when the temperature increases, what happens? Our solubility also increases,
Okay.
right? And vice versa.
Yes.
And this we use a solubility curve to find out what amount, what mass of crystals we will get after we cooled the saturated solution. Because we know that after we get saturated solution, there will be a crystallization process, right? Crystallization will happen and we get some mass of crystals, right? So this solubility curve is used to find out that mass of crystals, which mass of crystal we will get after cooling down the saturated solution. Okay, we will do some questions based on that, so that it can be more clear. So see here, see this, this is the NaCl graph. This line is for NaCl, right? And this is for,
Yeah.
okay. So see the solubility of NO3, potassium nitrate, it increases with the increasing temperature. And
Hmm.
this line goes dramatically. This is a curved line, right? We will get either curve graph or a straight line, right? But see, in the case of sodium chloride, or you can say KCl, or any other chloride form of salt form, you will get a linear type of a straight line graph. As you can see, there is hardly some changes in solubility with increase of temperature. See, the temperature increases, but there is hardly this change in solubility. In the case of sodium chloride, see this line. Consider this line. Yeah. So the solubility of sodium chloride or
Yes. Yes.
potassium chloride, it changes hardly with increasing temperature. Just remember that. But in other cases like potassium bromide, KBr, you can see some changes in the solubility with increase in temperature, right? And in a potassium nitrate, in this KNO3, you will get a sharp curvy type of graph. Okay, the temperature on the increasing temperature, the solubility increases dramatically. Okay, got it? So that's how we plot the solubility curve between the solubility and temperature.
Yes, I got it.
Got it? Yeah. So each point on the solubility curve shows how many grams can be dissolved at a specific temperature. Okay, at a specific temperature, you can find how many grams will be dissolved in a particular solvent. For example, let's talk about, see, for 40 degrees Celsius, right? When we talk about 40 degrees Celsius. So let's draw perpendicular from there, from x-axis. After that, let's draw perpendicular to y-axis. So what will be the solubility? So 80 grams will be 80 grams of, what is
40.
this?
The
This
temperature
is
will be 40.
Yes, the temperature is 40 degrees Celsius. So at a specific temperature at 40 degrees Celsius, how many grams of this is for potassium bromide. How many grams of potassium bromide will be dissolved in a solvent? 100 gram of solvent, so 80 grams of solute. Okay, that's how we can get the number of grams which can be dissolved at a specific temperature. For example, let's say another example. For example, see for at 80 degrees Celsius, we are talking about 80 degrees Celsius. So just do one thing, just draw perpendicular to the x-axis and perpendicular to the y-axis from here. So how many grams it is? 200 grams. Okay, so the solubility at
For temp.
yeah,
What's
at
that
80 degrees
solution?
Celsius. Yes.
The solution NaCl, sodium chloride oxide.
No, this is not for sodium chloride. Sodium chloride is here. This is for NaClO3, right, and KNO3 for both these, right, for potassium chloride
So
and
what?
for NaClO3. For both of them, at 80 degrees Celsius, solubility is 200 gram per 100 gram of solvent, which is
Okay,
clear.
clear.
Okay. Similarly, you can take another example like for NaCl. Talk about NaCl at 20 degrees Celsius. Let's draw perpendicular from here, and from here let's draw. So it's just 30 point something, 35 point something, between 20 and 40 degree, 40 gram, right? So it's between 20 and 40 is 35 point something, something gram, right? When you plot this in your graph sheet, then it will be more clear, right? 35 point approximately 7
Yes,
grams.
miss. Yes.
Okay, when you plot this graph on your graph sheet, then you will get the exact answer, accurate answer. I hope it is clear, Soumya. Clear?
Yes, yes, it's clear.
Okay. So let's do some questions based on this. Okay. So this is the graph given. So here's a question. How many grams of potassium bromide can dissolve in 100 gram of water at 20 degrees Celsius? So at 20 degrees Celsius, this is 20 degrees Celsius. We are talking about potassium bromide. Yes, 70.
70.
Yes. So just
Miss, the
once.
answer's there in yellow.
Yes.
The answer's already there on the slide.
Yes, yes. It's there in the slide. Don't say it, just do it by your own. Okay. Don't
Okay.
say the answer. So it is. So how many grams of potassium bromide which can be dissolved in 100 grams?
70.
Yes, 70.
Oh,
So what you have to do is at 20 degrees Celsius, just draw a perpendicular bisector, perpendicular to it. And from here, draw perpendicular on the y-axis. You will get the answer. It is between 60 and 80. So it will be 70 grams. Okay, so 70 grams of potassium bromide can dissolve in 100 gram of water at 20 degrees Celsius. That's how you will give answer in your exam. Okay, that's how you will write the answer. Okay, Soumya?
okay. Yes.
Okay, do the next one. Don't say the answer. Do the next one. So how many grams of
What's
potassium
the question?
nitrate
How
it
many
is?
grams of potassium nitrates?
Yes, can be dissolved in
100
100
grams.
gram of at 60 degrees Celsius it is.
130 grams.
Yes, so here 60 at 60 degrees Celsius, just draw perpendicular. Right. So we have asked P for KNO3 potassium nitrate. From here, just draw perpendicular to the y-axis. Right. So you will get the answer. It is between 120 to in between 120 and 140. So it is approximate to 130 gram. So 130 gram of potassium nitrate can dissolve in 100 gram of water. Right. That's how you will write the answer in your exam. Okay. That's a practice question.
Okay.
We have covered it. I've
How
discussed
many
it at
grams?
20. Yes, at 20 degrees Celsius. potassium bromide.
70?
Yes,
69.
69 point something
69.
it is. Yeah, 69 point
Mm,
something it is. So you can write the approximate value, which is 70 gram. Okay.
okay.
Okay, again for NaCl it is, right? So NaCl hardly changes with
Um,
it hardly the solubility hardly changes with temperature. Okay, so
yeah.
just they have asked at 100 degrees Celsius, right? So what will be the
Mm,
solubility from 100? Just draw the perpendicular.
41, 42-ish.
It's just like exact to 40, I think. When you draw, it is
Okay.
just exact 40 grams. Okay, so 40 grams of sodium chloride, it can dissolve in 100 gram of water at 100 degrees Celsius.
Mm,
Okay, this type of questions can be asked from this topic. Okay, clear, Soumya? Is there any doubt in
yes,
the
clear.
clear? Okay, just
Not really, no.
okay, just a second. Okay, now let's see your book. What is given in your book? Some examples. Yeah. So in your book, it's basically given two examples, KCl for KCl and KNO3, potassium nitrate and for potassium chloride it is. Right? So
Yes.
we have done it. So let's do some questions based on that, which are given in your book. Okay, so here's a question.
Mm. The table shows the solubility of potassium chloride at various temperatures.
Yes,
Plot a solubility curve for potassium chloride. So at 10, it would be at 31.2. So
we can draw it. Yeah, you have a graph paper? Do you have graph sheet?
no, I don't have any graph sheet at home.
Okay, I will give you a home assignment based on that. Just
Mm,
please do it on
okay,
your graph sheet. Okay, just draw this graph
okay,
on your graph sheet. Then you will get the
um,
exact value. Okay,
okay, Miss, will you assign it to me on the portal?
yeah, I will assign it to your portal.
And
I
Miss,
have
how do I
assigned,
submit it?
just submit it in the form PDF format.
Oh, PD? Okay.
PDF format you can submit.
Oh, PDF. Okay.
Yeah.
Miss, is it okay if it's online? The graph I draw is online.
Okay. If you get the accurate value, then it's okay. Otherwise, you can draw on the graph sheet also. If you draw on the
Okay.
graph sheet, it will be more clear to you, right? Okay, see, the examples given, which is given in your uh, book is, here's a question, that is a table is given, right? Table shows the solubility of potassium chloride at various temperatures, right? That you have asked this question, right? So the temperature at 10 degree, it is 31.2. At 30, it is 37.2, 40, 40, right? So that's how. So what you have to do is just plot a solubility versus temperature graph for this potassium chloride. Okay, on the graph sheet, just like
Okay.
that, right? Just like that. Here's the
On
given.
the specifically, it'll be only this question.
Not for this question. Whenever they have asked to plot a solubility curve graph, so then you have to draw that. Okay. When it is not
Yeah,
given,
but okay, okay, I got it.
yeah, but for
Yeah, the homework will be this question though.
no, this is not your homework. It will be
Oh,
assigned on
okay,
your portal. Okay, I will give you another
okay. And
example.
when is it due?
Yes,
When is the portal homework due?
I will give you after the class. Okay,
Okay, it'll be due next session.
I will inform the deadline. Here, the deadline will be there. Before the next
Okay,
class, you just have to do that. And if there is any doubt, please ask me in the next class. Okay,
okay,
okay. And yeah, after the completion of this chapter, I will provide you the PYQs also. a question based on previous year questions, right? And in
Okay.
the assignment itself, and if there is any doubt in those questions, please ask me in the next session. Okay? Got
Yes,
the-
yes.
Okay. So here's a question that plot a solubility curve for potassium chloride. Okay, so that's how you plot a first on the x-axis, just take a temperature in degrees Celsius, and on the y-axis, just put the solubility in gram per 100 gram of solvent, right? Solvent.
Okay.
Okay, so just take the 10 gap, right? A scale of 10, and here also the scale of 10. And when you plot the graph, you will get this type of a straight line. Okay, so on for potassium chloride, on increasing temperature, there is a slight change in the solubility also, right? Like that. Now here's some questions when you plot, because the plotting of graph is very, very
Mm.
important, right? After plotting the graph, you will be able to give all the answers, right? Like first question is, see the first question, use the
Sorry, miss, your
solubility.
voice is breaking.
Okay, I said that for this type of question, graphical
Miss,
question, I said for this type of question, for solubility curve graph type of question, you just need
can you
to,
hear me, miss?
yes, yes, Soumya, hello, Soumya,
Hi, miss, can you hear me?
yes, yes, I'm here. Hello, are you
Okay,
there?
sorry. I think there was an internet break.
It's okay.
Mm.
So is my screen visible now?
Yeah.
Yeah, okay. So I said this type of question, for this type of question, you really need to draw the graph first, right? Just draw the graph first and plot all these information on the graph. You will get the linear type of graph over here, right? After that, you will be able to give the answers, right? The drawing of graph is necessary. Now, you will give the answer one by one. So here, use the solubility curve to find. First one is the solubility of potassium chloride at 50 degrees Celsius. Now tell me what will be the potassium solubility of potassium chloride at 50 degrees Celsius. At 50 degrees Celsius. So what will be it? Just draw the perpendicular over here, right? And from here, just draw the perpendicular. So it's in between 40 to something, right?
Yeah. 44.
Approximately to 43, you can write 42 point something 5 gram,
Yeah.
right? Gram per 100 gram of water. It's necessary because the unit for solubility is gram per 100 gram of water. Okay, so what will be the solubility of potassium
Okay.
chloride at 50 degrees Celsius? It's 42.5 gram per 100 gram of water. Okay,
Okay. Miss, to what significant factor do we answer?
yes, significant figure.
To
Yes,
what?
no,
Two
that's why
significant figures?
yeah, one
Okay.
significant figures you can write. See, that's why I told you to just plot the graph on a graph sheet, right? So you will get the accurate
Mm.
answer. You will get the accurate answer. 42.5,
Mm.
you will get approximate. Okay. Now, the maximum mass of potassium chloride that would dissolve in 50 gram of water at 40 degrees Celsius. So how will you calculate this? Try it. Just try it, Soumya.
Um, since solubility is usually in 100, do we divide the answer we get by
What?
2?
Okay, just see.
Usually solubility is,
Yes, per 100 gram of
yeah.
solvent, right? So
So
here you
since this
can
is 50, don't we check at 80?
50 gram, which is a half of that 100. right? So it is half of that 100.
So
So
it
what
would
will be
be,
the, yeah, the
we'll
solubility
make
will
it
be,
100. So
yeah, just compare it by 100. So you will get, see, for at 40 degrees Celsius, what will be the solubility? At 40 degrees Celsius, the solubility is 40 for 100 gram of
yeah.
water, right? But if we talk
Hmm.
about in 50 gram of water, right? 50 gram is
Hmm.
half of 100 gram, right? Half of 100 gram of water.
Hmm.
So the solubility will also get
Yes.
halved, which is 20 gram. Half of 40, which is 20 gram. Clear, Soumya?
Hmm. Yes, clear.
Clear, right? So, and also we can
Yeah,
use
it's clear.
we can also use the formula like for maximum mass of solute which dissolves in gram is equals to, you can write down the formula also, this formula, mass of water, or you can say the mass of solvent upon in
Yeah.
100 gram into its solubility, just multiply it by its solubility, and the solubility is in gram or 100 gram. Okay, now using this same formula, just calculate the value for this. You will get the same answer over here. Like for what is the mass of water which is given? 50 gram, right? 50,
Uh,
100
yes.
into, and what
50.
was the solubility at 50, at 40 degrees Celsius? At 40 degrees Celsius, the solubility was 40.
40.
40. So you will get the same
Yeah.
answer. You will get same answer. Okay, you can calculate this maximum mass of solute dissolves by using this formula also. Okay.
Okay.
Okay, let's do the next question. The temperature at which crystals will first appear if you cooled a hot solution containing 51 gram of potassium chloride in 100 gram of water. So you have to find the temperature in which at which the crystals will first appear, right? If you cool a hot solution containing 51 gram of potassium chloride in 100 gram of water. First, tell me, have you written this? Because I'm going to erase this. Written?
Yes. Yes. It's written.
You're not well?
Yes.
Yeah, tell me. Yes, Soumya, tell me.
Miss, can you hear me?
Yes, Soumya. Yes, Soumya. Tell me what happened.
In the question?
Yeah, is there any doubt?
No, no, miss, I got the formula and notes.
Okay, for example, if I ask you on the basis of second question, right? If I ask you, find out the
Hmm.
maximum, just find the maximum mass, right? That
Hmm.
dissolve in 34.6 gram of water at 40 degrees Celsius. Tell me the answer. How will you calculate?
34.6 divided by 100
Yes,
times 40 because 40 reaches at 40.
that's good. That's how you will calculate using that formula. Okay.
Okay.
To the next one. So here, okay, so we know that what solubility means. The solubility measures the maximum mass of potassium chloride, right? Which will dissolve in
Mm.
100 gram of water at a particular temperature, right? And we know that crystals will start to appear as soon as the solution becomes saturated, right? We have discussed it in earlier class. Crystals will start to appear as
Yeah.
soon as the solution becomes saturated, right? So now see the graph over here. See the graph. Okay, just page number. Okay. Now see from the graph, it can be seen that at 90 degrees Celsius, see, at 90 degrees Celsius, more than, see, just draw perpendicular and draw a perpendicular over here, right? So we can see from the graph at 90 degrees Celsius, more than 51 gram of solid will be soluble, right? More than 51 gram of solid will be soluble. But as the solution cools down, like when the temperature decreases from 90 to 80 to 70, right? So when the temperature,
Mm.
when the solution cools down, what happens? The solubility also decreases, right? As you can see in the graph, what happens
Yes.
when the temperature decreases or the solution cools down, solubility also decreases, like 51. From 51, it goes uh, at 50, right? Because we know that solubility decreases with decreasing temperature, right? On decreasing temperature, the solubility also decreases. So just to draw this line across 51, this is
Mm.
51, sorry, just a second. Already the line has, okay. So when you draw the line over here, right? So it
Mm.
shows that 51 gram is the maximum mass that will dissolve in at 80 degrees Celsius, right? So from here you can see
Mm.
that 80 degrees Celsius, 51 gram is the maximum mass that will dissolve at 80 degrees Celsius. So we can say that crystals will first starts to appear at temperature below 80 degrees Celsius, because we know that when the crystals will start to appear as soon as the solution becomes saturated, means the maximum amount of solute has been dissolved in that solution, right? So the crystals will start
Mm.
to appear at that temperature. From here, the crystals will start to appear below 80 degrees Celsius. Clear or not? Should I repeat?
Clear. It's clear. It's clear.
Okay. You sure, Soumya? Clear?
Yes, this topic is clear.
Okay, okay. Good. Okay. So,
Miss, actually, I have one question.
yes, ask me.
What is the unit again? The unit that we use for solubility? Because
It's
I need
gram,
to write.
gram per 100 gram of solvent. Right.
Hmm.
This is the unit we used for solubility, gram per 100 gram of solvent. A solvent can be anything, water or any other solvent, ethanol, methanol, anything. Okay.
Okay.
Okay, the third question over here is yes. Okay. So here they have asked that what mass of potassium chloride would crystallize from the solution in B3? Means in the third part of B, what mass of potassium chloride would crystallize from the solution if the temperature fell to 10 degrees Celsius? From 90 to 10 degrees Celsius, when the temperature falls, then what will be the mass of potassium chloride would crystallize from the solution? Means they have asked the amount of
Mm.
crystals, right? So see,
Mm.
see, we know that at 10 degrees Celsius, the solubility, check the solubility over here from the graph. Just, what was the page number?
I think it was only 2 pages above.
Yeah, page number is 21.
Or 12.
Okay, so see here, just see the graph and tell me at 10 degrees Celsius, what is the solubility?
Or
Just draw the perpendicular over here, right?
and that goes to 32.
A 1 point something, right? So the
Hmm.
solubility at 10 degrees Celsius is 31.2 gram, right? 2 gram means per 100 gram of water. Okay, it means that 31.2 gram of KCl will stay in solution, right? 31.2
Yes.
gram of KCl will stay in the solution when the temperature is 10 degrees Celsius, right? So in part
Hmm.
B, what was that? In part B3, we have
Hmm.
started with 51 gram, right? We have started with 51 gram, which was at 90 degrees Celsius. See, in part B, 51.0 gram, which was at 90 degrees Celsius, right? So what will
Hmm.
be the mass of crystals will be?
Um,
Final was 51. At 90 degrees Celsius, it was 51 gram, right? Minus what was the at 10 degrees Celsius? So at 10 degree, it was 31.2 gram. Just subtract it and you will get the mass of crystals. Mass of crystals.
Miss, I
Fine.
don't think I understand the mass of
Okay.
crystals.
Okay. Okay. So the question says, what mass of potassium chloride would crystallizes from the solution in part B3, right? If the temperature fell to 10 degrees Celsius. So basically they have asked the total mass of potassium chloride that would crystallizes in the solution. Okay. So see the final
Hmm.
at 90 degrees Celsius, it was 51 gram. It was 51 gram. Means the final solubility was 51. And for initial one was at 10 degrees Celsius, which was 31.2. 31.
31.
So if I ask the mass of crystals, then what would you do? Final minus initial. 51 minus 31.2, right? So you will get the mass.
What's the formula for that?
Formula is final mass minus initial mass, which was at 10 degrees.
Final. Okay.
So you will get mass of crystal over here, right? So what does it mean? That 19.8 gram of KCl, it will crystallizes out. Will crystallizes out, right? And we know that crystals will start to appear as soon as the solution becomes saturated, right? So after
Right.
the solution becomes saturated, then 19.8 gram of KCl will crystallizes out. That's the final answer. Clear, Soumya?
Hmm. Yes.
Okay, that's so your first chapter is completed now. The states of matter is completed, and
Hmm.
now we are going to discuss the chapter questions. Okay, so one by one, you will tell
Hmm.
me the answer. The first one is basically a quiz.
What is the name?
Yes. What name is given to each of the following changes of a state?
Solid to liquid is melting.
Yes. Just
Liquid to solid is freezing.
or I told you another word for that. Another process which is fusion also. Right? From
Oh,
solid to liquid, it is fusion, or you can
yes.
say melting. Second one,
Yes. Liquid to solid is also freezing.
freezing, or you can use another word for that. solidification.
Mm. And then solid to gas, is that not sublimation?
Sublimation, good.
And gas to solid, I don't remember. I need to look at my notes from last time.
Yes. So from gas to liquid, you can say desublimation or deposition. Desublimation, or another word for this is deposition. Deposition.
Okay.
Okay. And these three, question number 2A is draw diagrams to show the arrangement of particles in a solid, a liquid, and a gas. So you know how to show the arrangement of particles in solid, liquid, or gas by dramatical method. See, like
Oh,
this.
yes.
I'm not going to draw here. See, so this is the arrangement of particles in solid, liquid, and gases, right? When the examiner asks you
Mm.
to draw, so that's how you can draw the arrangement of particles. That's how you can show the arrangements by using this diagram. Okay, and solid, liquid, and gas. Clear?
Oh, yes, sorry, I'm muted.
Okay, next question. Describe the difference between the movement of particles in a solid, liquid, and see, so only solid and liquid.
In a solid, the particles have less energy because their temperature is lower, and
Okay?
they don't move a lot. They are usually
They,
they have fixed shape and they have fixed volume,
they
and
only
they're
just add
usually
this also. They only vibrate at its own position, right? They
at
don't
a
move
fixed
here
position.
and
Yeah.
there. Yeah, at a fixed position they vibrate. They don't move here
Mm.
and there, right?
Mm.
And similarly, you can explain for liquid also. Next question is,
They have a fixed volume but not a fixed shape, and they move around a little bit in the area, and they have a medium amount of energy.
yes, yes. Good, Soumya. Next question. The change of a state from a liquid to a gas can be either evaporation or boiling. So explain the difference between evaporation and boiling.
Um, is it not the same?
Yes.
They both go from liquid to gas. I think
Uh,
boiling is for water, and evaporation is more
in both
natural.
the process, the change of a state from liquid to gas occurs, right? So evaporation is
Mm.
basically a surface phenomena. You can write it down. Evaporation is a surface phenomena, right? So where
Surface phenomena? What
yes,
does that mean?
surface phenomenon. Surface phenomena means evaporation always occurs at the surface of the container. For example, there is a container and
Mm.
particles are on the water liquid particles are on the surface, right? So evaporation will occur on the surface. Like only the surface particles gets evaporate out, not in the particles which are in the bulk. Okay? Not the liquid particles which are in the bottom will not evaporate first. The surface one will evaporate first, right? That's why we called it as a surface phenomena. Evaporation is a
Mm.
surface phenomena. You can write it down.
Yeah, I'm gonna write it
I
down.
can dictate you. Okay, so write it down. Evaporation is a surface phenomena where a liquid turns into a gas at any temperature.
Evaporation is a surface
Surface
level
phenomena
phenomenon.
where a liquid where a liquid turns into a gas at any temperature. Turns into a gas at any temperature below its boiling point.
At
Below
any
it?
temperature below its boiling point.
Yeah, yeah. Means in evaporation, there is no need of more temperature, right?
Oh, it can happen at any temperature below.
Yes, below its boiling point. While while boiling is a bulk phenomena.
How
While
is that possible that it can go below
it is
boiling point?
can go below its point, yes, evaporation can go below its boiling point.
I don't understand how. Like,
Means in evaporation you don't need 100 degrees Celsius. For example, for water, the evaporation can take place in 30 degrees Celsius also, 40 degrees Celsius also. It don't need a boiling point temperature, like high
then,
temperature.
then why does boiling need 100 degrees?
Because we know that boiling is a bulk phenomena, right? In which, in boiling, the high temperature is required, and we know that it involves a bubble formation. You can see the bubble formation in boiling, but why you can't see the bubble formation in evaporation? Due to the temperature difference, right?
Oh, okay.
Right? You have observed, right? In boiling, when you boil water, what happens? You can observe the bubble formation here. But in evaporation, you never see the bubble formation, right? That's due to the difference in temperature. Evaporation can take place below
Mm.
its boiling point at any temperature, but boiling happens at a specific temperature.
Oh, yes, okay. That's why
Okay?
in the shower, sometimes when you're using hot water, you can see steam, even though the water
Yes,
isn't 100 degrees.
yes, yes. Clear?
Yeah, clear.
So boiling is a bulk, write it down. Boiling is a
Yeah.
bulk phenomena where a liquid turns into a gas
Yeah, I wrote it down.
at a specific temperature, which is the boiling point. At a specific temperature, in bracket, you can write down the boiling point, and it involves bubble formation. And yeah, also, evaporation is relatively slow process as compared to boiling, right? Boiling is much faster process than evaporation.
But boiling requires a higher temperature, so
Yes, yes. That's why the particles move in a random motion, right? And it becomes faster.
Miss, I wrote it down.
Written? Okay. Okay, next question is the question refer to the substances in the table. Here's five substances are given: A, B, C, D, and E. Okay, and melting point and boiling point of these are given. What you have to do is just write down the physical state of each compound at 30 degrees Celsius, at minus 100 degrees Celsius, and 80 degrees Celsius. Tell me one by one. What at, okay, I'm writing the temperature here at 30 degrees Celsius. We're at minus 100 degrees Celsius here and 80 degrees Celsius. Now tell me what will be the physical state of these.
Um, Substance A, it will be a liquid. No,
How?
gas,
How?
because its boiling point is negative 253.
We know that substance is a solid below its melting point, right? Below its
Mm.
melting point, a substance is a solid, and between melting point and boiling point, a substance is a liquid. Okay, and above its boiling point, substance is a gas. Just keep in mind and answer those questions. Okay, so at 30 degrees Celsius, a substance A will,
At 30, it will be a gas. At negative 100, it will also be a gas. And
good.
at 80, it will also be a gas. All
Okay.
three of them.
Second, for substance B,
Mm. At 30 degrees, it will be liquid. At -100, it will be solid. And at 80, it will be liquid.
Good, Soumya. I think your concepts are clear now. Okay, tell me for third substance. Substance C.
Um, Sublimes?
Yeah.
What does sublimes mean?
Sublimes means it's sublimation. Sublimes means
Oh,
just changes directly from solid to gas, right? Without passing through a liquid phase.
oh, because the reaction is so quick. At 30, it will be a uh, but I don't know the boiling point, so it will either be a liquid or a gas.
How can you know the boiling point? It directly converted from solid to gas, and the boiling point is for liquid, right?
Oh, so it will be a solid.
Yes, good. So that type of question can came in your exam.
It will
Conceptual.
be solid.
So all the threes will be solid. Next one,
Yeah, that is a trick question.
yeah, D.
For D, that will be liquid
Liquid.
versus liquid, and
Yes.
then also liquid, and then at
No.
80, it will be
For
gas.
for 80 it will be yes, gas.
This I have a question.
Yes.
Isn't there also a fourth state of matter called plasma?
Yes. It's a fourth state.
What
Plasma and
temperature does it go? And
Bose-Einstein condensate. Right. Go all two more states of matter are there. Okay, but
hmm,
in your syllabus, it's only three states, right? In your
oh,
standard, we will cover only three states. That's why I haven't discussed that.
okay. Um, for E, the first one will be solid.
Hmm.
Um, Also solid,
Yes.
and then also solid.
Yes. Solid. Good. Okay. Next question is, which substance has the greatest distance between its particles at 25 degrees Celsius?
Um,
Among the
what
following,
subs?
among the following A, B, C, D, E, which substance has the greatest distance between its particles at 25 degrees Celsius?
Uh, um, the A.
It's good because A is gas, right?
Yeah.
You know, at 30 degrees Celsius, it is, and 25 is just nearer to 30
Close.
degrees Celsius, right? So you can
Hmm.
consume it as a gas. So gases particles are very far away from each other. So the greatest distance between its particle at 25 degrees Celsius is substance A. Okay. Next is, why is no boiling point given for substance C? I
Because
just
it's
explained
sublimate.
it. Yes. So how will you write the answer? Because substance C sublimes, right? What does it mean? Sublimes means it changes directly from a solid to gas without passing through a liquid phase. Therefore, there is no boiling point for substance C. Okay, you have to explain all these. Next is your, which liquid substance would evaporate most quickly in the open air at 25 degrees Celsius?
Um, Also substance A
How?
because
Substance
it's a
A.
gas.
See here, they have asked which liquid substance.
Oh,
It's a gas. It needs to condense first, right? Gas
um,
needs to condense first to
hmm.
a liquid. So it's not
Oh, so
possible.
it would be B because it's.
Yeah, it will be B because substance B would evaporate more quickly at 25 degrees Celsius, right? Because it is already in the
Hmm.
liquid phase. Okay,
Yeah,
that
and it's the
temperature.
closest to 25.
Yeah, and when we talk about the substance C, It needs to sublime first, right? Before it can
Mm.
evaporate. So your option, what will be the substance? It's substance B. Okay. Okay. Next question is your refer to figure 1.14, page number 7, in the diffusion experiment. Oh, just remember those experiment of diffusion. Okay, in which we take I think HCl, hydrochloric acid, right? Okay, let's see.
Mm.
On page number 7. Let's recall. Okay, this was the experiment. Remember the experiment? White ring was formed, right? White ring
Oh,
experiment. Here we will the cotton wool was soaked in a concentrated ammonia solution, and here the cotton wool was soaked in a concentrated hydrochloric solution, right? Then the diffusion
mm.
takes here, here a white ring forms, okay, which is more closer to the hydrochloric acid end. Why it is more closer to the hydrochloric acid end? Because of the
Because it has.
because of the high molecular weight, right?
Because of the what? Sorry.
Because of the high molecular weight, it is more heavier than this ammonia.
Mm.
Okay? So that's why the diffusion takes place more slowly. And for ammonia, the diffusion takes place faster, right?
Okay.
So, so here the white ring forms. See, what is the question? Here's the question. So, question number 1 here is explain why the ring takes few minutes to form. Why the ring takes few minutes, Soumya?
Because diffusion is a slow process,
Yes,
and gas particles are really far away from each other.
yes.
Yeah.
That's good. So that's how you can explain. You can write that the ring takes a few minutes to form because diffusion is a slow process, right? Diffusion is the process by which particles move from an area of high concentration to an area of low concentration, right?
Okay.
So this
Mm.
movement of particles takes time to spread out, right? And reach equilibrium, which results in the formation of the ring. Okay, that's how you can write your answer. Next question is, if you heat a gas, what effect will this have on this movement of particles? Tell me,
If
when you heat a gas, what will
the
happen?
particles will gain energy.
And there will be an increase in kinetic energy of the gas, right? And when
Yes,
the
because the
kinetic
heat
energy,
energy gets transferred into kinetic energy.
yes, yes, leading to an increase in the speed and random motion. Okay. Okay, next question is, in the light of your answer to 1, okay, continuation part is there, the continuation of first question. So, what
Mm.
difference would you find if you did this experiment outside on a day when the temperature was 2 degrees Celsius, right? When the temperature was 2 degrees Celsius instead of a warm lab, right?
It would
Instead
take
of,
longer because the gas would need to get to 100
yes,
degrees.
yes, yes, because the kinetic energy will decrease, right? When you conduct this experiment outside 2 degrees Celsius, what will happen? Because the temperature is very low, right?
Mm.
Which results in slower particle movement, right? And due to the decrease in kinetic energy, this would lead to a slower diffusion rate. Right? The rate of
Mm.
diffusion will be slower, and the formation of the ring would take longer compared to that in the warm lab condition, right? So that will be
Mm.
your answer. The rate of diffusion will get slow due to the decrease in kinetic energy. That's
Mm.
why it takes longer time to when we compare it to the warm lab condition. Okay.
Mm.
Okay. Next one. Explain why the ring was formed nearer the hydrochloric acid end of the tube.
Because it has a higher molecular weight.
Yes. Okay. And you can also use a dense word. HCl gas is more dense than the ammonia gas. Okay, and the denser gas diffuses more slowly. So, because the denser gas diffuses more slowly, it causes to travel a shorter distance before reacting with ammonia and forming the ring. Okay,
Yeah.
next is your okay. Here's a question. Suppose you replaced the concentrated. We have used the concentrated HCl in the experiment, right? So we
Yeah.
have just replaced this concentrated HCl with concentrated HBr, hydrogen bromide, right? So what will happen? This releases the gas hydrogen bromide. So what will happen when NH3? It will react with HBr, hydrogen bromide, right? So what will happen
Will
here
it be
in this case? In this case, hydrogen bromide also reacts with ammonia to form a white ring. So you have to suggest a name for the white ring in this case.
um um I'm not sure.
Even ammonia, see the last experiment, see on the page number 7. See here, what was that? You have just replaced the HCl by HBr, right? So when ammonia, it reacts with HBr, it forms ammonium chloride, right? So when ammonia reacts with hydrogen bromide, it will form ammonium bromide, right? NH4Br. Okay, got it?
Okay.
So what will be the name of white?
H4Br,
Yes, that's ammonium bromide.
ammonium chloride.
You don't know, need to write the formula, just write the name, ammonium bromide. Okay, next question is, hydrogen bromide particles are about twice as heavy as hydrogen chloride particles. Okay, see, the hydrogen bromide particles are twice as heavy as HCl particles. So what effects do you think this would have on the experiment?
Um, the ring would form closer to the hydrogen bromide.
Yes, and the diffusion will take place more slowly
Oh,
as compared to the hydrochloric acid particles. Okay, so you can write it down. The heavier HBr particles would diffuse more slowly compared to HCl particles, resulting in a slower rate of ring formation in the experiment. Got it?
got it.
Any problem?
No, not really.
Okay, so question number 5. See, tell me the answer. Use the
Use
words
the
given
words
below.
given below to complete the following paragraph. Sodium chloride dissolves in water to form a solution.
Yes. The water is
The
called
water
a
is called the solvent.
yes, and the sodium
The
chloride
sodium
is
chloride
a
is the solute.
yes. If the solution is heated to 50 degrees Celsius, some of the water what?
Evaporates
Yes,
until the
evaporates.
solution becomes
Becomes solution becomes saturated, right? Because we know that when the solution becomes saturated, the crystallization started. Okay, Soumya, are you there?
yes, clear.
Okay. And yeah, I think the time is up. I have the class. So this is your homework, Soumya. So this
Yes.
is a very easy question based on the solubility curve graph, right? So this is your homework. You have to plot the graph first, and after the plotting of graph, answer these questions. Okay. Okay,
Yes.
Soumya.
Yeah.
Okay. In next lecture, what we are going to start? You said that you want to start this organic chemistry,
Chapter 22, because that's what I'm
chapter
doing in
20.
lessons right now.
Okay, so we will start the introduction to organic chemistry in the next class. Okay,
Okay.
and
Yeah.
I will give you assignment. Just please do that